This video is to help you complete the sample work for Unit 2 in Geometry B. And Unit 2 is polygons and quadrilaterals. I'm going to take it lesson by lesson. You'll find the key words usually on the second slide of each lesson. And you'll find it under objectives. So you'll find objectives and then find keywords. So the first lesson, Unit 2, Lesson 1, has the keywords equiangular polygon, equilateral polygon, and regular polygon, all referring to polygons. So I'm going to leave the word polygon out and just to simplify things. So meaning equal, lateral edge or side. Okay, so all sides congruent. Okay, and an example of such a thing is a rhombus. Okay, where all four sides are equal length. Okay, next word, equiangular. Equiangular. All angles congruent. An example of that is a rectangle. In a rectangle, all the angles are 90 degrees, so all the angles are congruent. And let me leave off the square corner and just specify that they are congruent. All the angles are congruent. Equiangular. And if we combine both words, then we have a regular polygon. Regular. All sides and angles congruent. And a perfect example of that is a square. All the sides are the same length and all the angles are the same measure. Regular. Okay, let's go to Lesson 2. Lesson 2, second slide. Okay, talking about properties of parallelograms. Okay, the first word is consecutive angles. Consecutive angles. Okay. Angles next to, or in order. In a polygon or in a parallelogram, angles 1 and 2 are consecutive. They are next to each other. And that goes with the idea that consecutive angles are supplementary. They add to 180 in a parallelogram. Consecutive angle. Opposite angles. Okay. Angles across from each other. So in this parallelogram, angles 1 and 3 are opposite angles. And opposite angles of a parallelogram are congruent. Opposite sides. Okay, our angles are not sides, not angles, opposite sides. Our sides across from each other. Okay, in this parallelogram, this side is opposite this side. And opposite sides are congruent in a parallelogram, one of the properties. Parallelogram. Should have started with this word. Note they've put the words not in logical order, but in alphabetical order. Parallelogram. It's a four-sided, or I'll say, let's simplify, it's a quadrilateral. That means it has four sides. With two sets of parallel sides. Okay, so the definition does not include congruent angles or congruent sides. It's parallel. It's all about parallel. The root of the word is parallel. So these parallel arrows indicate the opposite sides are parallel. The other properties are true. Opposite angles are congruent and opposite sides are congruent. And adjacent angles or consecutive angles are supplementary, but those are properties, not part of the definition. Definition is two sets of parallels. Okay, let's go on to lesson 3. Lesson 3. Okay, lesson 3 has an objective but no keywords, and that's okay. Not every lesson has new keywords. But if you're on the objective page, you're on the right page. So you don't need to look for keywords elsewhere. Objectives and keywords. All right, lesson 4 is about properties of rhombuses, rectangles, and squares, and it has 3 vocabulary words: rectangle, rhombus, and square. Okay, so the definition of rectangle is when a truck carrying a bunch of yarn collides with a truck carrying a bunch of string. You get a rectangle. Not really. It's a quadrilateral, so it's got 4 sides with 4 right angles. Quadrilateral with 4 right angles. That's the definition of a rectangle. Note that we don't mention anything about opposite sides being congruent or opposite sides being parallel. The definition is just 4 right angles. You got 4 right angles, you're a quadrilateral, or you're a rectangle, and you're a quadrilateral. Okay, rhombus. Rhombus. Definition of rhombus. It's quadrilateral. That means it has 4 sides with 4 congruent sides. So you could also say it is an equilateral quadrilateral. Hence our inclusion of it as our example for equilateral as well. Okay? All 4 sides are congruent. Rhombus. Square. Okay, a square is a quadrilateral with 4 congruent sides and 4 right angles. So it's the combination of a rectangle. It's a rectangle and a rhombus and 4 right angles. Okay, so it's a combination of a rhombus and a rectangle. It's got 4 right angles and all 4 sides are congruent. So a square is both a rhombus and a rectangle. And I don't know what I wrote on rectangle there. Let me fix that. That's rectangle, not rectation. Weird. Must mean something. Rectangle. Glad I caught that. All right. So that's it for lesson 4. Let's go on. Lesson 5, conditions for rhombuses, rectangles, and squares. Slide 2. As an objective, but no keywords, so no new words for lesson 5. Lesson 6, go to slide 2. We've got a few. We're exploring trapezoids and kites. Okay, I'm going to reposition the screen here. Okay, and let's go here to the first word. We have kite and trapezoid. I'm going to start with trapezoid, and I'm going to sneeze here in a moment. There we go. Bless me. Trapezoid. Quadrilateral, so it's got 4 sides. Almost should just leave quadrilateral off of all these because they're all quadrilaterals. But quadrilateral with exactly 1 pair of parallels. And that word exactly is necessary because it rules out calling a parallelogram a trapezoid. 1 pair of sides is parallel, the other pair is not. That is the definition of trapezoid. Okay. Whereas, and let's go through the vocabulary associated with trapezoid. Base. Now, base applies in other circumstances, but base in particularly of a trapezoid. The base is 1 of the parallel sides. Okay, so this is a base, and this is a base. So a trapezoid actually has 2 bases. The 2 parallel sides are both called bases, and we call them base 1 and base 2 in the area formula. Okay, leg. Okay, 1 of the non-parallel. So I'm going to parallel with a slash sides. So I'm just going to label it over here. Leg, leg. 1 of the non-parallel sides is called a leg. Okay. Let's do mid-segment of a trapezoid. Mid-segment, particularly in regards to a trapezoid. Mid-segment. It's a segment, and we can have mid-segment of a triangle too, connecting the midpoint of the legs. Okay, so here's a trapezoid. Find the midpoint of the legs and connect them. That's a mid-segment. And we had a rule for finding the length of the mid-segment. It was the average of the bases. Okay. So we've done leg, mid-segment. All right, base. Oh, base angle. Okay. 2 angles touching the base, or touching a base. Okay, so this is a base angle, and this is a base angle. And in an isosceles trapezoid, which we're going to do next, the base angles are congruent. Isosceles trapezoid. It's a trapezoid with congruent legs. So the non-parallel sides are congruent. Basically, what it amounts to is a triangle that's got its top cut off. An isosceles triangle. So the non-parallel sides, the legs, are congruent to each other. Isosceles trapezoid. And we learned that the base angles of an isosceles trapezoid are congruent. All right, so now kite. Kite. It's a quadrilateral, 4 sides. with two unique, that word unique is important, pairs of adjacent, that means next to, congruent sides. That means the sides that are congruent are adjacent. They're together. And they're unique in that they're not the same as each other. So the top two are different from the bottom two, the way I've drawn it. The top two are different from the bottom two. Okay? So two unique pairs of adjacent congruent sides. That's a kite. And we learned the diagonals of a kite are perpendicular. And the main major axis divides it into two congruent triangles. Okay. Kite. All right, that's it for lesson 6. All right, so lesson 7, polygons in the coordinate plane. No vocabulary words there. Lesson 8, applying coordinate geometry. Coordinate proof. Coordinate proof. Okay, so coordinate proof. Okay, so using coordinates and formulas to prove things. Example, prove A 2 1 B 4 2 and C, let's do -1 3 and D, let's see, 1 4. So prove, I should have said given this, prove AB is parallel to CD. Okay, and I would say by the distance formula, not the distance formula. To prove they're parallel, we need the slope formula. By the slope formula, the slope of AB is change in y